Chaos, Unreal Engine's high-performance physics destruction system. With Chaos, you can completely control massive scale levels of destruction whilst achieving cinematic quality visuals in real time. This destruction is achieved using 4 core components: geometry collections that define which objects are going to be destroyed, fracturing, which defines how these collections are destroyed, clustering that defines the different levels in which collections are destroyed, and fields, which apply behaviors and effects onto collections within regions of space. Destruction within the Chaos system starts with a geometry collection asset. This can be built from one or more static meshes or blueprints containing static meshes. The easiest way to create a geometry collection is to drag the static mesh to which you want to apply chaos destruction into your level, or use the default editor cube and scale its z-axis to 4 to resemble a pillar. Then we navigate to the fracture mode tool and press the new button under the generate header. Now we select the directory to which you want to save the new collection asset. You also give it a name, such as gc_destructible pillar example, GC standing for geometry collection. Now that we have our geometry collection, we need to define how we want to break it up during destruction. In Chaos terms, this is called fracturing. There are several types of methods available for achieving this, and combining these will lead to more interesting looking destruction. All these methods are based off the Voronoi pattern, which is a way of partitioning an object by using a set number of points, also known as sites. We use these to define regions of 3D space which contain all the points within our object which are closest to that site. These regions are also known as Voronoi cells. To perform fracturing on our geometry collection, make sure it's selected in the level editor and navigate to the fracture section of the fracture mode tool. Then we select the fracture type which we want our object to have. We'll select the uniform fracture pattern, which will fracture our pillar into pieces of similar volume. In this case, we set the minimum and maximum of our generator to 20 so that it splits our pillar into 20 fractures. We can toggle the draw sites option to visually see where our sites have been created and change the seed number to change this. We'll also apply some noise to our fracture so that it looks more organic. Then we generate our fracture by pressing the fracture button. To easily visualize our newly generated fractures, we can use the keybind Shift-E to increase their exploded view percentage, or Shift-Q to decrease it. You will also have noticed that this fracture hierarchy window has opened up. This is a useful tool for debugging and selecting specific parts of your fracture, allowing you to switch between bone index and name view. To fracture one of our regions even further, simply select it, choose the fracture type settings, and press fracture. As you can see, both visually and in the fracture hierarchy, our region has been fractured into another sub-region containing 20 more fractures. What this has done is create an additional level of destruction. As it stands, our pillar has 3 of these. Level 0, the initial state of our pillar, Level 1, our first 20 region fracture, and Level 2, our second 20 region fracture. In order to visualize one of these levels at a time, you can use the Shift-W key to go down the level or Shift-S to go up a level. These levels of destruction are also referred to as clusters. The cluster tools are often used to control the visual quality and performance of a fractured mesh. A common use case is specifying different damage thresholds for each cluster in your fracture. To do this, navigate to the Chaos Physics section of your geometry collection in the Details panel, and under the cluster settings you'll see a damage threshold array. The array represents the level of your cluster to which the damage threshold corresponds to. So in our case, the value in index 0 defines the amount of damage required to break apart our pillar into our first 20 fracture cluster, and index 1 defines the damage to further break our pillar into the level 2 cluster. If we set index 0 to 800 and index 1 to 1 million, you can see that our second cluster never breaks apart. But if we set our index 1 to something like 200, then both of them break. Note that you can set these values in the details panel on a per actor basis as we did here, or you could set them directly in the geometry collection asset. When clustering, it can be useful to see the number of fractures within each cluster. To do this, select your pillar and type in this console command. You'll see the result in your output log. The final component of Chaos which we'll talk about is the system fields. These fields are used to affect simulations of chaos objects by occupying a region of space and applying different behaviors and breakage effects in that space. There are 3 main types of physics fields. Transient fields, which are created, executed, and destroyed at runtime during a function call or event. These are used to add a temporary effect to the physics simulation. Then we have construction fields, which are created in the construction script of the field blueprint. And finally we have the persistent fields, which are created and remain active until they're explicitly removed. Each of these fields applies to a specific physics type. Fields can also use different types of metadata to add additional information on how they behave. We'll create a cluster strain field, which will decay and break away the center of our pillar, resulting in its eventual collapse. As field systems are currently in beta, you need to enable this plugin manually in the plugins window. After you've done that and restarted your editor, navigate to your content browser. Right-click and select Blueprint Class. Toggle the All Classes option and search for Field System. Select the field system actor and name it BP_strain field. Double-click this asset to open up its blueprint editor. With the field system component selected, click the Add button and search for and select Sphere Collision. In the Details panel, set the sphere radius to 64. Then, under the Rendering category, disable the Hidden in-game checkbox. This way we can visualize the collision area of our field during debugging. Now navigate to your event graph and drag in your field system component. Drag off this node and search for Add Transient Field. Toggle the Enable Field flag and set the physics type to External Strain. What this does is apply an external strain to any geometry collections inside of its area, and then break them if the value of the strain is greater than the damage threshold of the geometry. Now drag off the Begin Play node and search for the Delay node. Then connect this into your newly added transient field. We'll then add a radial fall-off component and set its value. Drag the output of this node into the field node parameter of the transient field. So that we can alter our strain strength from the Details panel in the editor, right-click the radial fall-off's magnitude attribute and promote it to a variable. Set it to be instance editable by pressing the I button, then compile and set its default value to 500,000. Next, we get our sphere's scaled radius as well as its world location, and connect these into the radial fall-off node. Finally, we compile and save the blueprint. Drag this blueprint into your level and place it where you want your strain to occur. To make the simulation seem more realistic, set the pillar's damage threshold to 500,000 and 5,000. At this point, we've barely scratched the surface of what you can do with Chaos Destruction. If you're interested in learning how to build more cool effects using Chaos, such as how to integrate it with the Niagara VFX system, then don't subscribe so that you don't get notified when I release my Niagara series. And if you don't know what Niagara is, then don't check out my video on an introduction to Niagara in 300 seconds. That's it for this one, guys. Tell somebody you love them, and I'll see you in the next one.